All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to learn, among many other things, how to find the equation of a line from tables and descriptions. This lesson covers TEKS 2B, 2C, 2D, 2I, 3A, and 3B. The prior knowledge that you bring to the table, again, among many other things, but the prior knowledge directly appertaining to this lesson, is that you learned how to use the point slope formula, y minus y1 equals m, open parentheses, x minus x1, close parentheses, to find equations in slope-intercept y equals mx plus b form. The big question we want to answer, among many smaller questions in this lesson, is how do you write equations when you are not given the slope or the y-intercept? Okay, so that's what we're going to tackle today. This is a fairly big lesson, so there's a lot involved. I need you to buckle in and get ready to do some work. All right, we'll start with this warm-up. Write an equation for number one here. Write an equation in slope-intercept form given, and we're given a point and a slope. So we need to use the point-slope formula to solve this or figure it out. First thing we need to do is label our points x1, y1. Okay, now we have to know the point-slope formula. Okay, so that would be y minus y1 equals m, open parentheses, x minus x1, close parentheses. Now, we're given all the information we need here, so we write y minus, and then y1 is 2, equals slope of m equals -3, so -3, open parentheses, x minus x1, x minus -1, close parentheses. Okay? Make sure you get that written down. Now, right away, I see that we can bring these two negatives together to make a positive. And now I'll distribute the -3. Through the parentheses. So I have y minus 2 equals -3x minus 3. Now I add 2 to both sides. And I have y equals -3x. -3 plus 2 is -1 minus 1. Okay, so there is the equation in slope-intercept form. Number 2, what is the rate of change of this linear equation? Well, we really need to solve for y, get it in slope-intercept form, and then we'll know where the m position is, what the slope is when we find out what m is. So first I need to distribute this -4 inside the parentheses, and I'll write 3y plus 1 equals -4x minus 4. Now I'll subtract 1 from both sides. Okay, I have 3y equals -4x. -4 minus 1 is -5. So 3y equals -4x minus 5. Now I'll divide through each term by 3. Cancel out the 3's, and I have y equals negative 4/3 x minus 5/3. The rate of change is just the slope, m. So now that we have this in slope-intercept form, we can identify that the rate of change is negative 4/3. Okay, number 3. Write this linear equation in slope-intercept form. So it's given to us in standard form. We've got to solve for y. 8x plus 3y equals negative 15. Step 1 is to subtract 8x from both sides. I have 3y equals negative 8x minus 15. Divide through each term by 3. Cancel the 3's on the left, and I get y equals negative 8/3 x. 15 divided by 3 is 5, so minus 5. Okay, so that's the equation in slope-intercept form. Here we're asked to simplify. We're given 4x to the negative 4th times y squared times 3x to the 1/2 power. Okay, so there's a lot of exponent rules being thrown at you all at once. The first exponent rule that's being thrown at you is the negative exponent rule. So over here, we need to remember our negative exponent rule. X to the negative 4th equals 1 over x to the 4th. Okay, I need to know that. What else do I need to know? I need to know that x to the 1/2 power is going to be treated just like any other exponent. So when I apply the product rule to it, I'm just going to deal with it like it's any other exponent. Okay, so let's take this one step at a time. First, I'm going to rewrite this expression with this x to the 4th term down on the bottom. Okay? Well, I don't really need to do that. There's a simpler way. We'll do that at the end. I'll tell you what we're going to do. We're going to group our terms in a clever way that allows us to apply the product property to our exponents. Okay, so there's multiple ways to solve this. Look what I have. Look what I really have here. I have 4 times x to the negative 4th times y squared times 3 times x to the 1/2. Everything is just multiplied. So I can move these terms around without changing anything. I can just move them around. For example, I can pull this 4 times 3. I can pull that out here to the left. Then I can group my x's together. So times x to the negative 4th times x to the 1/2 times y squared. Okay, so 4 times 3 is 12. I can write 12 there. And now I need to apply the product rule of exponents when I multiply these two bases are the same, x to the negative 4th times x to the 1/2. So let's go over here. X to the negative 4th times x to the 1/2. Now when I do that, I add the exponents, okay? So I have to add negative 4 to 1/2. So it would be good to write negative 4 as negative 8 over 2. So I can add those exponents. So x to the negative 8 over 2 times x to the 1/2. Now, when I do that, I can add the exponents. By multiplying the bases together, I add the exponents. So you're going to add together negative 8 over 2 and 1 over 2. So you're going to get negative 7 over 2. So this will reduce down to x to the negative 7 over 2. Okay, so I'll write that here. X to the negative 7 over 2 times y squared. Okay, so now I'll apply the negative exponent rule. X to the negative 7 over 2 is equal to 1 over x to the 7 over 2. So think about what I have now. I'm going to put this in the denominator. Okay, that's basically what I'm doing. So now I'll have 12y squared over x to the 7 over 2. Okay, so I've simplified that. Okay, number 5, solve for x. And here you've got another load of stuff thrown at you. First, you have the power rule. Okay, you have an exponent raised to another exponent. You've also got a number raised to an exponent. So remember the power rule. X to the a raised to the power b equals x to the a times b. And so you're also given the square root. We need to remember that the square root of x can be written as x to the 1/2. Okay, so we've got to remember that. We'll deal with the other rules in a moment, but that'll get us for now. So what we need to do first is distribute multiply this 2 exponent here to each term inside the parentheses. Now 4 has an exponent of 1. Okay, so when I multiply, I'm going to multiply 2 times 1 there. So let's go to a new line here so you can see what we're doing. You have 4 to the 1 times 2, which is 4 squared. X to the 4 times 2, which is x to the 8th. Times, so these are all multiplied, times x to the 1/2. All right, all of that is divided by 8x squared. And that's set equal to 32. Okay, so now I need to bring some of this stuff out. I need to reorganize my situation here so I know what I'm dealing with. First, I need to pull these numbers out and deal with them on their own. 4 squared is 16. So out here I'll write 16. Okay, we'll deal with this fraction. And then over here I'll write the 8. We'll be able to simplify that here in a minute. Right here I'll put the x squared. These are multiplied together. In the numerator, I have x to the 8th times x to the 1/2. So the bases are the same. I apply the product rule. So x to the 8th, I need to write as x to the 16 over 2. Okay, so x to the 16 over 2 plus 1 over 2. All right, that will be x to the 17 over 2. Okay. And So I'll write that here, times x to the 17 over 2. All of that is set equal to 32. Okay, now I have to apply the quotient rule. So 16 divided by 8 is just going to be 2. So this becomes 2. Now I apply the quotient rule. X to the 17 over 2 divided by x squared is going to be x to the 17 over 2 minus 2. So x, let me write this, x to the 17 over 2 divided by x squared is going to be x to the 17 over 2 minus 2. This is the quotient rule here. I need to write 2 in terms of 2, so I'll write 4 over 2. This is x to the 17 minus 4 over 2. 17 minus 4 is 13, so this equals x to the 13 over 2. Okay, so 2 times x to the 13 halves equals 32. Okay, so now I'll divide both sides by 2. Now I have x to the 13 halves equals 16. Okay, so in order to solve this, I need to think about what 13 halves really means. What I can do to get rid of this is I can create a power rule situation where I'm going to multiply out by 2 to the 13th. So I'm going to raise this expression to the reciprocal of the exponent. Because when I apply the power rule, I will cancel here and here. But I also have to bring 16 to the power of 2/13. Okay? So we cancel, 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 cancel. And now x is by itself. X equals 16 to the 2/13 power. All right? Let's think about what that is. 16 to the 2/13 power. What that means is we're taking the 13th root of 16 squared. All right? It's easier to put it into a calculator. You just put 16 and you raise that to this fractional power 2 over 13. You get 1.531966357. Okay? So x equals 1.531966357. And that's just an approximation. Okay? If you wanted to leave this in a form that would be exact, you would write x, let me put it here, you would write x equals the 13th root of 16 squared. Okay, and that would be fine. Okay, number 6. Graph 4x plus 3y equals 3. So here we're going to subtract 4x from both sides. We have 3y equals negative 4x plus 3. We're going to divide each term by 3. cancel, cancel, and we have y equals negative 4/3 x plus 1. To graph that, I go find the y-intercept, which is 1, and plot it in. And now I'll go down 4 over 3. Down 1, 2, 3, 4 over 1, 2, 3. Okay. So let's plot that line in here. I should plot one more point. 1, 2, 3, 4, 1, 2, 3. There. Now I really know where to put the protractor. Okay, so that's that equation graphed. Okay, so that was the warm-up. Here's the lesson content. How to find the equation of a line from tables without the y-intercept and from written descriptions. It's a three-step process. First, we find the rate of change to ensure it's constant. If it is not the same for every pair, you're dealing with a nonlinear equation. You can't proceed. Step 2, pick a pair of x and y values and use the point slope formula, y minus y1 equals m, open parentheses, x minus x1, to plug in your x1, y1, and m. Remember this, the constant rate of change is the slope. So when you find the rate of change, you're finding the slope for linear equations. Step 3, solve the equation for y and arrange terms so that they are in slope-intercept or y equals mx plus b form. Okay, here's an example. Find the equation of a line for this data. First thing I need to do is go through and compute the rate of change and make sure that each of these ratios ends up being the same. So what's happening between, on the x side, what's happening between negative 2 and 1? Okay, plus 3. That's the change in x. Between 1 and 3, it's plus 2. Between 3 and 6, it's plus 3. Okay, from negative 17 to 4, that is plus, well, we go 17 plus 4, what is that, 21? Plus 21. From 4 to 18, what is that, 14? Plus 14. And from 18 to 39, that's 21. Okay, so this is the change in y. Well, now I need to compute the change in y over the change in x, because that was one of our definitions of slope. M equals change in y over change in x. I'm just dividing 21 by 3, and I get 7. And I'm dividing 14 by 2, and I get 7. And I'm dividing 21 by 3, and I get 7. So in each case, I find that the slope is 7. These are all the same, so I'm ready to proceed. Okay? Now, we just choose a pair of points. And the easiest one that I see here is 1 and 4. It doesn't matter which pair of points you choose. Because remember, the point slope formula just needs a point and a slope. So our point that we're going to use is 1, 4. Okay? And the slope we're going to use is 7. All right? So this is going to be x1 and this is going to be y1. Now I use the point slope formula. I have y minus y1 equals m, open parentheses, x minus x1, close parentheses. Let's plug in what we have. Y minus 4 equals 7, open parentheses, x minus 1, close parentheses. I have to distribute this 7 through each term in the parentheses. So I have y minus 4 equals 7x minus 7. Now add 4 to both sides. And I have y equals 7x minus 3. Okay, so that's the equation. This is the process that you use each time. So you can now find, this is big power that you've acquired, you can now find an equation of a line even when none of these value pairs contains the y-intercept. You can determine the y-intercept is -3 and that the slope is 7. All right? I would watch this again, just so you understand. I'd go back and I'd watch this whole process again, because now we're going to move into word problems, and these can be tricky. So make sure you understand this before moving on. Okay, so I've got a fun problem here. Many people are interested in mythology. This comes from Greek mythology, from Homer's Iliad. This is one of the stories about the Trojan War, the main story. In the story of the Trojan War, the king of Troy has a daughter, and the king of Argos from Greece, his name is Agamemnon, he takes the daughter, okay? The god Apollo gets really angry, and so he fires his arrow, many of them, he fires many arrows down on the Greeks as they're landing on the shores of Troy. And that's actually a metaphor for the Black Plague. So he's basically giving plague to all the Greeks. But in the book, in the Iliad, it's anthropomorphized as shooting arrows at the Greeks. Okay, so this is God fighting on the side, a god fighting on the side of the Trojans. Right? We always think of the Greeks as the heroes of this, but Apollo is fighting on the side of the Trojans. So let's read what's happening here. Find the speed of Apollo's arrow as it flies from his bow atop the citadel of Troy towards the Greeks on the shores of Ilium. Ilium's just another word for Troy. To avenge the kidnapping of Trojan king Priam's daughter by the proud and haughty Agamemnon, king of Argos and his legions. Then write a linear equation to model the arrow's path. Okay, so that's a fun problem. Here's the data about the arrow. Okay, we're given time and we're given distance. Before we do anything else, we have to remember that time is the independent variable and distance is the dependent variable. So time is going to be x and distance is going to be y. And once we've established which is x and which is y, we follow this process right here, totally unchanged. Just go through and compute the change in x and the change in y. So we'll do change in x here, and we'll do change in y here. So from 1 to 2, that's plus 1. From 2 to 5, that's plus 3. From 5 to 9, that's plus 4. From 20 to 5, that's minus 15. It makes sense that it's going down because Apollo would be shooting his arrow down at the Greeks. Because the Greeks are on the shore of the water, and Apollo would be up on top of the tower in the middle of Troy, way up on a hill, way up on a mountain. So he's shooting down at the Greeks with the arrow. Okay, so from 5 to -40, what is that? -45 minus 45. And from -40 to -100, well, that's minus 60. Okay, so now we need to compute the change in y over the change in x. Make sure that they're all the same. So this is m. That's the slope when we get that. So negative 15 over 1 is negative 15. Negative 45 over 3 can be reduced down to negative 15. Negative 60 over 4, well, you think about a clock, you got 60 minutes in an hour. That can be broken up into 4 pieces. Each piece is 15 minutes, so 60 over 4 is just 15. Put a negative in front of it, negative 15. So the slope is the same, and that means that the slope is negative 15. Now we just pick a pair of points. It almost sounds like that Peter picked a peck of pickled peppers. Peter Piper picked a peck of pickled peppers. So we're going to pick a pair of points. Peter Piper picked a pair of points. So we'll choose points 2 and 5. They seem easy to work with. So we now have a point and a slope. We have 2, 5. And we have slope of negative 15. M equals negative 15. Okay, we can work with this. We just write down the point slope formula. Y minus y1 equals m open parentheses x minus x1 close parentheses. Write it down every time so you don't forget it. Now we'll label our points x1, y1 and plug them in. Y minus 5 equals, m is negative 15, so negative 15 open parentheses x minus x1, which is 2. Let's distribute, multiply this negative 15 through both terms in the parentheses. So I have y minus 5 equals negative 15x plus 30. Okay, so now I need to add 5 to both sides. And I get y equals negative 15x plus 35. And that's the equation for Apollo's arrow. Cool. That's this example worked here. I'll let y'all finish writing that. I'll just bring it here so you can see it. If you haven't read about the Trojan War, it's really one of the most fundamental stories in human existence. It's something you should read about. The Trojan War happens before the Odyssey. So first you have the Iliad, then you have the Odyssey. So if you haven't already, go and pick up a copy of Homer's Iliad and Odyssey. You can find like translations of it in story form, so you're not having to read a complicated poem. But I actually think the poem is pretty easy to read. I think you'd like it. Okay. So I'm going to move on here. Okay, next example. Now, as we look at this example, we're going to read through it. You're going to see that there's no table given. See, there's no table, so we're going to actually have to create a table. We're going to have to read very, very carefully in order to create this table. So let's see what this example says. Rumpelstiltskin is busy helping the miller's daughter spin straw into gold. So this one's about the story of Rumpelstiltskin. I hope they're still teaching you this story. I think this comes from the Brothers Grimm. So if you're into the fairy tales and stuff, Rumpelstiltskin, very good story. Rumpelstiltskin is a troll. Okay, he's like a little troll. They call him an imp, I-M-P. He's a troll, and what happens is the king locks this miller's daughter up in the tower. All right, and she has to spin straw into gold, but she can't because she's just a human being. But this little troll comes along. He's like a little leprechaun dude or a troll, and he tells the miller's daughter. He says, "Look, I'll make a deal with you. I will spin your straw into gold, but you have to give me your firstborn child." All right. And so he actually ends up helping her spin the straw into gold. And then, if I remember the story correctly, he then demands that she has to give him the firstborn kid. And she doesn't want to do that. So he makes another deal with her. He says, "Okay, I'll give you 3 chances to guess my name." Okay, now his name is Rumpelstiltskin. It's like the most complicated name ever. So he thinks she can't get it. But she sits there and she tries and she tries. And then on the third try, his mouth is watering. He's going to get this kid. He's probably going to eat the kid or something. Who knows? And she says, "Oh, I think your name is Rumpelstiltskin." And I can't remember how the story ends, but he freaks out, and she gets to keep her kid, or maybe he takes the kid anyway. I don't know. You know how these fairy tales are like there's a kid version of them, and then there's the really scary real version that's like terrifying. It's creepy. Anyway, this is the story of Rumpelstiltskin. So Rumpelstiltskin is busy helping the miller's daughter spin straw into gold while she's locked away in the tower by the king. At 8 a.m., he has only straw. Okay. By 11 a.m., he has 8 yards of gold. At 2 p.m., he has 13 yards of gold. At 5 p.m., he has 18 yards of gold spun. Write a linear equation to model Rumpelstiltskin's progress. Okay, so what we need to figure out here is what's going on with the time, because the time's going to be confusing. We need to turn time into numbers. So look, at 8 a.m., all right, that represents our 0, right? So we're converting 8 to our 0 because it says here at 8 a.m. he has only straw, so he has no gold at 8 a.m. Now by 11 a.m. he has 8 yards of gold. So how many hours are there between 8 and 11? Between 8 and 11 there are 3 hours, okay? So at 11 a.m. this is hour 3. And at hour 3, he has 8 yards of gold. Okay, now we're kind of on a roll. At 2 p.m., he has 15 yards of gold. So he had 0 yards of gold at 8 a.m. So at time 0, he had 0 yards of gold. At time 3, he had 8 yards of gold. So now we're given 2 p.m. here. 2 p.m. How many hours are there between 11 a.m. and 2 p.m.? So let's see, 11, 12, 1, 2. There's 3 hours. Okay, so now we're at hour 6. So he's been working for 6 hours. And he has 13 yards of gold. We're forming our table, all right? Now at 5 p.m., okay, well, how many hours has passed since the start of the day, right? So from 2 to 5, let's see, 2, 3, 4, 5, that's 3 hours. So 6 plus 3 is 9. So at the 9th hour, he has 18 yards of gold. This is the table we need. Just this part right here. Right here. All right, so this is time. So this is going to be X, and this is the amount of gold, and that's going to be Y. So we'll go down here, we'll write our table out in a way that we can work with it. So now we have X and Y, 3, 8, 6, 13, 9, 18. And this is always the tricky part, like how do you create the table? Well, let's just hope that we don't get a lot of time where you get the time of day problems, because those can be tricky. Because you have to convert the time of day into numbers. Okay. So Now we can just do what we did on the other two problems we've done so far. First thing we do is compute the change in x and the change in y. Change in x, change in y. So from 3 to 6, well, that's plus 3. From 6 to 9, well, that's plus 3. Okay, from 8 to 13, well, that's plus 5. From 13 to 18, that's plus 5. So my slope will be equal to the change in y over the change in x. It's the same process every time, folks. So y over x here would be 5 over 3. And we're just going to write it as 5/3. And here y over x would be 5 over 3. So we're just going to write it as 5/3. Those are the same. Okay, so m equals 5/3. Now we just choose a pair of points. This one looks easiest, the 3 and the 8. So we've chosen our point. So now I've got a point and a slope. I've got 3, 8. And I have m equals 5/3. Okay, well now I write, well this is x1 and this is y1. Now I'll write the point slope formula, y minus y1 equals m, open parentheses, x minus x1, close parentheses. So I have y minus 8 equals 5/3, open parentheses, x minus 3, close parentheses. Okay, so now I'm going to distribute 5/3 through the parentheses. And I have y minus 8 on the left, unchanged, equals 5/3 x minus 5/3 times 3. Okay, this one might be worth some side work here just so we don't make a mistake. So this is 5/3 times -3. And that's -3 over 1. So you end up with -15 over 3, which is just -5. So we just put 5/3 x minus 5. Now we add a to both sides. And I have y equals 5/3 x plus 3. -5 plus 8 plus 3. There's the equation for how Rumpelstiltskin turns straw into gold. Okay? On to the next example. All right. This is the story of the princess and the pea. So the previous story came from the Brothers Grimm. The Princess and the Pea was written by Hans Christian Andersen. So if you're into fairy tales, this one's for you. To see if a woman was a real princess, this lunatic prince put a pea on the floor and started stacking mattresses on it to see if the woman could feel the pea through the mattresses, okay, through them. At first, he put down 21 mattresses. So on the first night, the way the story is, he puts down more and more mattresses every night until he's convinced that she's a princess. So on the first night, he puts down 21 mattresses. By the third night, he'd put down 27 mattresses. By the 8th night, he'd put down 42 mattresses. The woman still felt the pea, so the prince gave up and married her. Write a linear equation to model the prince's efforts to discover whether the woman was a real princess. Okay, so this one's a little bit easier. Over here in side work, I'm going to show you how to do this. So we have days, or we should say nights. We have night, and we have mattresses. All right, let's just list out the data. It says here on the first night, he put down 21 mattresses. On the third night, he put down 27 mattresses. By the 8th night, he put down 42 mattresses. Okay, so we see our table. Now, night is a form of time, so this is going to be X, and mattresses is going to be Y. This is the independent variable, this is the dependent variable. So, let's bring it down here and create our table. X, Y. We have 1, 3, 8, and we have 21, 27, 42. Okay, so we got our table. Right, so now we just need to compute the change in the X's and the change in the Y's. So I've got change in X here, change in Y here. From 1 to 3, well, that's plus 2. From 3 to 8, well, that's plus 5. From 21 to 27, well, that's plus 6. From 27 to 42, ugh. So from 30 to 42 would be 12 plus 3. Okay, so that would be plus 15. Now I compute M equals the change in Y over the change in X. Okay? So we'll compute Y over X, 6 over 2, well, that's just 3. 15 over 5, well, that's just 3. Okay, so M is 3. Now we just need to choose a point. And, you know, this is the easiest point, 1, 21. And we'll have to work with these bigger numbers this time. So we have a point 1, 21. And we have M equals 3. Okay, so this is X1 and this is Y1. Now write down your point slope formula. Y minus Y1 equals M, open parentheses, X minus X1, close parentheses. And now we'll substitute in everything we know. Y minus 21 equals M is 3, open parentheses, X minus 1, close parentheses. I need to distribute the 3. We have Y minus 21 equals 3X minus 3. And now I add 21 to both sides. And I get Y equals 3X. And now negative 3 plus 21. What is that? So that would be 18, right? Plus 18. There's the equation. Let y'all get that written down here. Okay, so now we'll move on. Now we're on to our homework problems. And that's great because we're right at the 50-minute mark. These are the homework problems that we'll be doing. And I don't know what I want to do with this. To make this into a second video or just solve them all here. And I think I'm going to make it into a second video because this would be homework and I don't want to quite give away the game. So I think I'll stop the video here and then we'll take a look at these homework problems in another video so that I can time the release of that video. So let's go over what we learned today. Let's go backwards. We learned how to read through a word problem and create a table of data, and then compute the change in the x's and the change in the y's and pick a point, and then use our point slope formula to solve for an equation. All right. And then we worked out a number of problems here. The two that I don't think I'll assign are these exponent problems and these radical problems here. So number 4, that took a little bit long. Number 5 was something that ended up requiring a calculator. You know, I didn't like that one at all. So for our warm-up, we'll just do 1, 2, 3, and 6. Or 1, 2, 3, and 6 when we get into class, and then we'll work through these problems, and that will take less than 50 minutes. Good. So that's a good lesson. You know, I hope you enjoyed I tried to give it a, you know, the legends and mythology and fables spin, so you'd have something a little bit interesting to think about. The homework is fairly involved, so I'll make that into a separate video, but for now, that's all I've got for you. Thank you so much for watching. This video might be worth a second look, especially if we skip past 4 and 5. But thank you again. Y'all make sure to like the video if you watched it, so I can see that people are watching this video. And if you have not already, please subscribe to the channel so you're always updated when I release new videos, such as the solutions to this big homework assignment. Thanks a lot.